The James Webb Space Telescope, which was launched in December, has been gradually powering up its equipment and unfurling its sunshield, and is currently aligning its mirrors in preparation for operation. The potential to directly photograph planets circling faraway stars, and perhaps, just maybe, find indications of life is one enticing feature that JWST has that Hubble does not. Based on the information stored in the wavelengths of light that reach the telescope lens, a single pixel snapshot of a faraway planet may just have enough information to tell us if biological life exists there. What about intelligent life, though? Could the JWST identify civilizations like ours? How would we go about looking for them? Understanding what humanity's existence on Earth appears like from space provides the greatest answers. We emit waste heat from industry and residences, for example, and artificial light at night, but probably more importantly, we make chemicals that fill our atmosphere with molecules that would not be there otherwise. These man-made air elements may be the item that alerts a distant extraterrestrial culture exploring the cosmos with their own powerful telescope. However, we may look for artificial lights from habitable worlds orbiting other stars. Proxima b, a planet in the habitable zone of our nearest neighbor. The dwarf star Proxima Centauri, which is 4.25 light-years distant, is the closest. Proxima b is assumed to be tidally locked, with perpetual dayside and nightside, since it is 20 times closer to its dim star than the Earth is to the brilliant Sun, just as the Moon faces Earth with the same side at all times. A sophisticated civilization on Proxima b may decide to move heat and power from the warm, lighted day side to the cold, dark night side. For example, the day side may be coated with photovoltaic cells that produce power from starlight. Future telescopes might detect significant covering of the day side by solar panels, based on the spectral edge that they exhibit in their reflectance of starlight. This brings up an intriguing hypothetical question. If the night side of Proxima b is lighted by artificial light, would we be able to detect it with Hubble's successor, the James Webb Space Telescope? We calculated the light curve that would be anticipated from a partly illuminated Proxima b as it orbited its star. According to our predictions, JWST will be able to detect light-emitting diode, LED, lighting on its night side, accounting for 5% of the stellar illumination on its day side. Even if the artificial illumination is as dim as our civilization now uses, 0.01%, on Earth's night side, JWST might detect it if it was constrained to a frequency range 1,000 times smaller than the starlight. Future observatories, like as the projected Large Ultraviolet Optical Infrared Surveyor, LUVOIR, will be able to detect even fainter amounts of artificial illumination on Proxima b's night side. The hunt for city lights on inhabited planets may appear speculative, yet it is worthwhile to pursue as a possible technosignature. With planned sensors, Proxima b circles its star every 11.2 days. Giving its probable occupants 32.6 more chances to celebrate their birthdays than we do on Earth, once every 365.2 days. If the signal was detected by future telescopes, the strong demand for bright lights during birthday parties on the night side of Proxima b would be reason for us to rejoice as well.